Section 3.6, proportional and non-proportional relationships. Essential question. How do you identify if a graph or equation is proportional? So something is proportional if the graph goes through the origin. Now remember that the origin is the coordinate point 0, 0. So if I draw a coordinate grid here, my line is proportional if it goes through that origin. So 0, 0. Non-proportional means that the graph does not go through the origin. So it does not go through the point 0, 0. So if I draw a line that does not go through the origin, it might look like this. So this graph did go through the origin right here. This graph does not go through the origin. It does not go through my blue dot. All right, so this table shows the number of miles traveled for each hour driven. So we need to do 3 things with the table. We need to graph the data, we need to write an equation, and we need to figure out how many miles we could drive in 8 hours and determine if it's proportional. So a bunch of things we need to do with this problem. So first of all, I'm going to move this graph to the upper right-hand corner here. Okay. So our x-axis is always the top row, so hours. So hours is what we're going to label our x-axis. So we have 1, 2, 3, and 4 hours that we need. So 1, 2, 3, 4. Our y-axis is the miles. So I'm going to count those by 50. So 50, 100, 150, 200. All right, then I'm going to go ahead and graph all 4 of those points. So after 1 hour, we went 50 miles. 2 hours was 100 miles. 3 hours was 150 miles. 4 hours was 200 miles. And then I'm going to go ahead and connect those dots with a line. All right, I have the graph of my data. So I'm going to make this a little bit smaller and move it up to the corner. All right, so let's keep working down this list. So we're done with letter A. Now let's go to letter B. It says write an equation to describe the relationship. So part B, we need to write an equation, and that means we need it to be in y equals mx plus b form, or f of x equals mx plus b. So remember that m is our slope. So we need to figure out what is the slope of our line. There's a couple ways you could do that, but I think the easiest is just doing rise over run. So if I pick 2 dots on my line, let's say this one and this one, and I'm going to do rise over 1, run. So I'm rising from 50 to 100. So I rose from 50 to 100, so that means I rose 50. And then I'm going to run from 1 to 2. So 1 to 2 is just 1. So 50 over 1 is just 50. So my slope was 50 over 1, which is just 50. Rise 50, run 1. Now I need to figure out my B, my y-intercept. So where does my line cross the y-axis? Now we can look at this graph and it looks like it crosses the y-axis right in the corner there at 0. But we need to look at our table and double check. Now if you remember, your y-intercept is a coordinate point that is always 0, comma something. And we don't know what that second number is. So, if I put a 0 in for x in my table, that will help me figure out what my y coordinate is. So, my pattern here goes 0, 1, 2, 3, 4. So I was just adding 1 each time. The bottom, I'm adding 50 each time. So that would mean that this number would be 0. Because 0 to 50 is 50, 50 to 100 is 50, 100 to 150 is 50, and so on. So 0 to 50 would also be 50. So my y coordinate is 0, so that means that my y-intercept is 0. Or I could just leave it out of the problem. Okay, so we did letter B. We wrote an equation to describe the relationship. Now let's find the number of miles driven in 8 hours. So keep in mind my hours is my x value. So that means that I'm going to need to plug in 8 for x. Because 8 hours is my x value. Hours are my x value. So y equals 50 times 8. And then I don't need the plus 0 because that's not going to make a difference. So y equals 5 times 8 is 40. Add another 0. So 400. So if I drove for 8 hours, I could drive 400 miles. My number of miles is 400. All right, so we're done with part C. Now let's do part D. Is this function proportional? Well, let's go back to our vocab word. Proportional means the graph goes through the origin. So does our graph go through the origin? Yep, and if you look at our table, we have the ordered pair 0, 0, meaning our graph would go through that point. So D is proportional. So yes, we'll say yes, proportional. So our line goes through the origin. All right. Second example. This table shows the cost for a certain number of t-shirts. So now we again need to graph the data. So x is our number of t-shirts, y is our cost. So number of t-shirts goes on the x-axis, cost goes on the y-axis. So our t-shirts goes up by 2s. So 2, 4, 6, 8, now I can go up to 10. And then our cost, you'll notice that the first number is 20, but then it's going up by 10s, 20, 30, 40, 50. So I would go by 10s. 10, 20, 30, 40. So then if I graph my 4 ordered pairs, 220, 430, 640, and 850. So if I connect those, there is my line. So I am done with part A. All right, we're done with part A. So part B, write an equation to describe the relationship. And again, we want this equation to be in mx plus b form. All right, so the first thing I need to do is count my slope. That is my m. M is slope. So I'm going to pick 2 points on my line and count my rise and run. So I'll just pick the first 2. So I'm rising from 20 to 30, so I rise 10. And I'm running from 2 to 4, so I'm running 2. 10 over 2 is 5. So that means that my slope is 5. My B, my y-intercept, if you look at my graph, it doesn't look like this one's going to cross in the origin. So let's figure out what that exact y-intercept would be. Well, remember that I said whenever we have our y-intercept where our line crosses the y-axis, the ordered pair is always going to be 0, comma, something, whatever that y-intercept is. So if I plug a 0 into my table, let's figure out what y is. So notice the top is counting by 2, 0, 2, 4, 6, 8. The bottom, I have to figure out what number would come before 20. Well, we said from 20 to 30 it was 10, 30 to 40 was 10, 40 to 50 is 10. So 10 to 20 would also be 10. So that means that 0, 10 is my y-intercept. So 10 is what I'm going to plug in here. So what that means is that even if I get 0 t-shirts, I still have to pay a cost of $10. So that might be like a processing fee for the order, or maybe the person is going to make $10 making the shirts for the customer. But there's a charge of $10 no matter how many shirts or if you're going to place an order, you have to pay $10. So that's what this one means. All right, let's go to part C because we're done with part B. So find the cost for 20 t-shirts. Now remember, the number of t-shirts is our x value. So we're going to plug 20 into our equation for x. So y equals 5 times 20 plus 10. Well, 5 times 20 is 100. 100 plus 10 is $110. So it costs $110 to get 20 t-shirts made. And part D, is this function proportional? Well, did our line go through the y-intercept, or go through the origin? No. It went through right here at 10. So this one is no, not proportional. Not proportional. All right. Now I'm going to move the directions for this. Oops. I lost my dots. That's okay. I'll put in some dots here. All right. So let's have one dot go here and one dot go here. All right. So here's the directions for this one. Write an equation in function notation to represent this graph. So when they say write an equation in function notation, they mean f of x equals mx plus b. Determine if the situation is proportional or non-proportional. So m is always our slope, which is the same as our rise over run. Our B is our y-intercept, or where the line crosses the y-axis. Where the line crosses the y-axis. Okay, so let's start with the slope. So we've already got our 2 red dots on there so we can count our slope. So we're going, I always like to start at the dot furthest to the left. So rise 1, run 2. So my slope is rising 1, running 2. And then if I look, where does my line cross the y-axis? The y-axis is right here. So my blue line and the y-axis intersect right here. So that's my y-intercept. And that number is a positive 2. So the equation for my line is f of x equals 1/2 x plus 2. The final question I have to answer is if it's proportional. Well, this one doesn't go through the origin. It doesn't go through 0, 0. So it is non-proportional. It does not go through the origin. Another way you can look is if your y-intercept is 0, it's proportional. If your y-intercept is not 0, it's non-proportional. All right, second one. Directions are the same, so I'm not going to, or I'll scroll it so you can see some of them there. There you go. Okay, so again, we need to write an equation in function notation, so mx plus b, where m is our slope, and b is our y-intercept. So if I count my rise and run from the dot furthest to the left, starting there, I go down 1, so -1, and run 1, 2, 3. So down 1 over 3. Down 1 over 3. All right. And then our y-intercept, look and see where our line crosses the y-axis. Here's the y-axis. My blue line intersects the y-axis right here, which is at the number 0. So you can put in plus 0 if you want to. Otherwise, if you just had f of x equals -1/3 x, that would be correct as well. Either of those work. So now if I look at my line, it does go through the origin, so it is proportional. You could also look, and if you have a y-intercept of 0, that's the other way to tell that your line is proportional. All right. Same thing again. F of x equals mx plus b. So m is my slope, so I'll start at my dot furthest to the left and count my rise and run. So rise 1, 2, 3, 4, 5. Run 1, 2, 3. So 5 over 3 is my m. My line crosses the y-axis right here, and that is at the number 3. My line does not go through the origin. It has a y-intercept of 3, so it is non-proportional. So I start at my dot furthest to the left, rise, -1, 2, 3, 4, 5, so down 5, over 1, 2, 3, so -5/3. And my line crosses the y-axis right here. So my y-intercept is 0. So this time maybe instead of putting plus 0, I'll just erase it. And since it goes through 0, it is non-proportional. Oh, sorry. Excuse me. Proportional. Summary.